Here we are going to show the standard matrix of a linear transformation involving the first one here, a linear transformation from R2 to R3, and the second one is from R3 to R2. To show, we need to start looking at our domain, okay? Unlike the previous videos where our domain and codomain are of the same space, here we have R2 to R3. We are expected to use vectors that are element of R2, and the result will be vectors that are element of R3. On the second one, we have vectors element of R3, and the result will be for R2. To show the standard matrix, we are going to again focus on the domain and get its 1, 0, 0, 1 standard matrix for R2. Okay, and with that, we are going to take out here the first column being 1, 0, and the second column being 0 and 1. These two vectors, now represented by this column matrix or column space, would be substituted in our transformation to determine the result or the standard matrix in R3. Next here, of course, this is R3. We are going to use 1, 0, 0. We have 0, 1, 0, and then 0, 0, 1. This would mean our first column. Okay, you will have 1, 0, 0. Okay. Next, you are going to use E sub 2. The second column here, you have 0, 1, 0. And finally, for our third, you will have here 0, 0, and 1. Then let's start with the first here, the linear transformation of our first vector here, which is linear transformation of 1, 0. In short, we will have x as 1 and y is 0. So we will have here 1 plus 0, 1, and then 0. Our result is in R3, 1, 1, and 0. Okay? Next here would be for our second vector. We are linear transformation. Of course, by the way, before we proceed, we could rewrite this as linear transformation of 1, 0 being the result now. We have 1, 1, 0. Okay? Element of R3. So we have here 0 and 1, where x is 0 and y is 1. So you'll have here 0 plus 1. That's 0 and then 1 here. In short, the result here is 1, 0, and 1. You could also rewrite in this form. 1 is equal to 1, 0, and then 1. So the standard matrix of our first linear transformation is the augmented matrix of the result. Oh, that's 1, by the way. 2. Okay. We have here this form. Okay. 1, 1, 0. And we have here 1, 0, and then 1. This is now the standard matrix of our linear transformation. Now, how do we know if our standard matrix is correct? Look at this, since this is the standard matrix for our linear transformation. Okay, and we are going to multiply this with a certain later on x and y components. Okay, that's what I meant by standard matrix. Take note that it is defined. Okay, this means that in our the number of columns that could be formed is still the domain of R2, which is 2. Okay, that's the hint of determining the final result, whether it's correct or not. Because if you're going to interchange it saying 1, 1, 0, 1, 0, 1, because you're thinking of R3 as the result, when you multiply this with your xy, as you move to its linear transformation, it's no longer defined. So let me erase it like, okay, let me erase this first. Okay, let's proceed to the second here. So we have these 3 different vectors here. So E sub 1 is the linear transformation of 1, 0, 0. So our x is 1, y is 0, and z is 0. But of course, there's no z here. So anyway, let's try to also complete this. So you have x, that's 1 minus 2 times 0. And then 2 times 1 plus 0. So the first result here, it should be in R2 because that's our codomain. You have here -1, or it's step by step, 1 minus 0. You have 2 plus 0. So we have here 1 and 2. Sorry, 1 and 2. Next, we'll have here this form, 0, 1, and then 0. So x0, 0 minus y, which is 1. And then you have here 2 times 0 plus 1. So that's 0 minus 2, 0 plus 1. So the form here is -2 and +1. By the way, if you're going to use this form here, 1, 0, 0 is equal to a vector 1 and 2. This area here will have 0, 1, 0. Okay. This is -2 and then 1. Then for our third, that's 0, 0, 1. But it's z that is 1, and we don't have z in this form. So we'll be using 0 minus 2 times 0, 2 times 0 plus 0. So we have here the result, which is 0 and 0. So we'll have the linear transformation of 0, 0, 1 is equal to 0 and 0. Combining all these three, you will have here e sub 1, linear transformation of e sub 2, and the linear transformation of e sub 3 is equal to, let's start with that, 1 and 2, this, -2 and 1, and of course this final 0, 0. Again, you would know that your answer is correct because the number of columns here is still the dimension of your domain, which is a 3. So this is how we show the standard matrix of a linear transformation with the dimension of your domain and codomain be not the same. Thank you very much for watching.